Hello, this is Nikki Jackson from Southwest Tennessee Community College, and this video is showing you a few examples from Self-Check 1.1 from Math 1710 Pre-Calculus. As you can see, it's right here, this particular problem right here is representing a function of x squared plus y squared equals 25. Well, we wanted to see, does this equation define y as a function of x? So that's one of the first things that we want to do. Now, the way that we determine that, we're going to solve for y first. So that's what we're going to do first. So my apologies if it's going in and out. I'm trying to zoom in and out so we can have like full optimal visualization. You also may have looked at this video as well, something very similar to it, when Melissa or either Foray went over this in stcc.mylabs+. But again, these are direct examples coming from the self-check. So as previously stated, let's try to determine or answer this question. Does this equation define y as a function of x? First, we're going to solve for y. So I rewrote the equation. Notice how on this step right here, we have y isolated. So now we got y squared equals 25 minus x squared. So what I did right there was subtract x squared from both sides. The next step is trying to isolate all of the variable of y by itself. Notice how right here you have y squared. So the opposite of something being squared is going to be the square root. The answer to that question is no. Now the reason why, again, the reason why we have the square root, that's the opposite of something being squared. Now a root can be both positive and negative. For example, negative 2 times negative 2 gives you positive 4. But a positive 2 times a positive 2 also gives you positive 4. Hence, the square root of 4 is positive and negative 2. Well, since you have two possible answers, it is not a function because there are two y values, one being one being positive and one being negative. Another example provided for you, dealing with your self-check for 1.1, would be this one right here. Now, I've already written out the answer, so again, my apologies for me zooming in and out on everything, but I want to make sure that we're able to use this. So provided for you is this graph. Notice how you have your vertical, which is your y-axis, and your horizontal, which is your x-axis. And normally we read from left to right. So if we're reading from left to right, we're looking at the x-axis first. So I'm going to scoot this over just a little bit, and hopefully you'll be able to see it. And my apologies for my penmanship. But notice how if you're reading it from left to right, right here, for your x-axis, it starts at negative 4. But then it ends at negative 9. So everybody see that? But that's negative 9 on the y-axis. Notice how the x version is 0. Hence your domain is negative 4 and 0. Now notice the way that it's written. You have a parentheses for the negative 4 for your x value. But you have a bracket at the 0. Remember, we're looking at the x-axis. Now the reason why you're looking at the bracket, that is a closed version. So when it's a closed dot, you're using the bracket. When it's an open dot, you're actually using your parentheses. So remember right here, your domain is from your x-axis. You're reading it from left to right. Now it wants to know your range. Where your range, and again, my penmanship kind of, it's not the best. You have your y-axis, and you're going to start up and down. So again, we're looking at the graph from left to right. Notice for your x part, it's right here. And we're going up and down. Oops, I didn't mean to draw, y'all. Sorry. So I bet I won't draw anymore, so can't erase it right now because we're doing live recording. So oopsie. But if you look at it from up and down, you have negative 9, and then you have the positive 7. Again, you have your open and your close. So when it is open, that's going to be your parentheses part. And then we're looking at negative 9, hence the bracket. Again, we're looking at it up and down. If I zoom in a little bit closer, and again, my apologies for the scribble scrabble. Notice how this graph crosses the x-axis. It looks like it's at negative 3. which it is. So therefore, your x-intercept is -3. Notice how the same graph, it crosses the y-axis at -9. Now here comes the tricky part. It wants you to find the value of the function where f is -2. That's just another way of saying that where does the graph cross the y-axis where x is -2? So if we go back here to the graph, remember we're looking at x being -2. And again, my apologies for the mistakes, but we're all human. So please forgive me in advance. Where x is going to be -2. So here goes -2 on the x-axis. We're going to go down to the graph where it stops. And it looks like that it stops at -5. Therefore, when you actually have your f of -2, your answer is 5. We're going to have one more example. Now, while we're doing that, let me see if I can erase all of this out the way. Yay! Here's another example in your self-check. Again, right now you may notice that all of 1.1 is dealing with functions. So here goes your graph. And I'm going to zoom in as possible where you see that. Please be mindful, this is just an additional resource of what Melissa and Fourier has already shown you. So this particular graph looks like it's almost like absolute value. It wants you to find the domain, the range, any x-intercepts, and any y-intercept if possible. So that's what it's asking for. So remember, your domain is dealing with your x values, which is looking at it from left to right. Your range is going from up and down. So we just pay close attention to this. Notice how you have your arrows right here, and that means they keep going in opposite directions. Therefore, that means your domain is going to be -infinity and +infinity because it continuously moves into the left direction, which is going more negative, into the right direction, which is more positive. Now we have the range. Remember, that's your y-axis. It has a stopping point there. Now, if we zoom in on this graph, you can see where it stops at. So if we're looking at it from up and down, looks like it keeps going downward. Notice how it's pointing downward, which represents -infinity. But if we're looking at this from down to up, it stops right here. It has a maximum point. It has a peak. Therefore, it's -1. So if we're looking at the range using interval notation, because you're going from down to up, downward is going to be -infinity, and then it stops right there at -1. Now, unlike what we did in the previous example where we were dealing with the dots for the open and close, no dots are available here. However, infinity, whether it's negative or positive, will always have a parentheses because it cannot be bounded. Whereas at -1, it's considered bounded. Now, what I mean by bounded, it stops. You can actually see where the graph stops at -1. Moving on to your x-intercepts and your y-intercepts. There are no x-intercepts because it does not cross the x-axis. However, it does have a y-intercept. And once again, we're going to zoom in if possible. And your y-intercept is going to be -5. Then part E. And I'm going to move this up so we can see everything. Part E has 2 parts. Oh yeah, by the way, you guys, have you noticed that I printed out the answers already? You can do the same if you have access to a printer. You can easily print off your homework and your self-checks once you have submitted it. Now, it won't do it while you're actually doing it live, but be mindful that your self-checks, you can do it over and over again. Now, all I have to do is just take your highest score. So if you want to print it out and do multiple versions of it so you can get additional practice, I encourage you to do that. And you can also have the option of printing out your answers. Now with this right here, back to part E. Part E is asking to find the function's value where f is -5 and f is 0. So going back to your graph, let's look for where x is negative 5. So 1, 2, 3, 4, 5. When it's negative 5, going to the blue line, your y value is negative 2. And then when f is 0, that means x is 0, go down to your x value, which is your blue line, you're going to have negative 5. So when your f of negative 5, that's going to be negative 2. Then your f of 0 is going to be negative 5. So again, this part right here is simply asking you when your x value is negative 5, your y value is negative 2. When your x value is 0, your y value is negative 5. Here goes another example pertaining to graphing. Now, hopefully, majority of you have already read the introductory letter and navigated through pause. The TI-83 or TI-84 graphing calculator is a requirement for this course, so that's why you have me writing down, like, see, use calculator. There will also be a free version available to you, and I'm going to provide that link to you in pause. So make sure you actually navigate through pause under your content tab very, vigorously, because it has a lot of stuff in there. So, what this is requiring, and if you just read it carefully, is dealing with shifting, meaning whether you're going to move it to left or right, or it's going to get skinny, or it's going to get wide. Is it going to go left, right, up, or down? And I've already said it, left, right, up, or down. So, quick summary. Whenever it's squared, you know that it's actually dealing with a parabola, hence it's going to be graphed like a U. Notice how you have a negative in front of the x squared, so now your parabola is upside down. So we can always already estimate that since we have negative x squared, it's going to be downward. But if we go back to what it's actually asking, I know it's going to go up 8 units. Notice I know up because what type of 8 is that? That is a positive 8. So the answer is C. But seeing is believing. So here's your calculator. Once I put it on, I'm going to hit my Y equal key and hit clear if by any chance you have anything up in here. So hit clear. Your f of x is going to be negative. Make sure you know that your negative is not the same thing as your minus. So here goes negative. Here goes your x. And here goes squared. And I'm going to hit enter. So y1 represents f of x. Now for g of x, that is going to be represented by y2. So once again, that's negative x squared. Now we're going to do plus 8. Hit enter to lock it in. Now we're going to graph it. So in the upper right hand corner, hit graph. That is your first one. That's your second one. But I'm going to make it a little bit easier. I'm going to hit zoom now. Now I'm going to go to zoom standard. Because my graph may not look exactly like yours. My graph looks like that now. Which yours might look like. It kind of reminds me of the Star Trek version, for those who are actually Trekkies like I am. But again, this one is your x squared or negative x squared. And notice how g of x shifted it up 8 times. Hence is a little bit taller. So yay, we know how to use the calculator a little bit. And here's your last example from the self-check. So again, I've written all over the place. So my apologies for my penmanship. So for this one right here, it's asking you whether or not it's a function. Well, there are several ways to determine if it's a function or not. One of the main ways you do it is simply restate it. Do any of your x values repeat? That's what this little scribble scrabble is right here. So I rewrote it in table form. I have my x values on the left side, my y values on the right side. So I took these ordered pairs and split them apart, just like a pair of shoes. So I have 4 and 1, 5 and 4, 9 and 9. Notice how none of the x values repeat themselves. Therefore, that's why it is a yes. Check that out. Your domain is going to be your x values. Hence, you have your 4, 5, 9. And I just rewrote the answers over here. And your range is your y values. So you have 1, 4, 9. Even though the 9s repeat right here, there's still two different entities. One is for your x values. The other one is for your y values. And I misspoke earlier. I said that was going to be your last example. It is not. This one is. This is asking you to evaluate a function. So your function is represented by f of x equals 9x plus 5. So we got a lot of different things going on right here. Your first example is asking you to find f of 8. So that means wherever I see an x, I'm going to put this 8 in. So I'm going to go ahead and simplify. 9 times 8 is 72 plus 5. So my final answer is 77. But then I have another example as well. Now it wants to know, what are you going to use when you have f of x plus 3? So once again, we're going to substitute wherever we see an x plus 3 plus 5. So using the distributive property, that means whatever's on the outside multiplied by each term on the inside. I have 9x plus 27 plus 5. Continue to simplify, so now you have 9x plus 32. Then your last one is asking you to find f of x where x is negative. So notice again, wherever I see an x, I'm going to substitute whatever's in the parentheses. So now you got negative 9x plus 5. Simplify, you got negative 9x plus 5. So ladies, gentlemen, individuals, all my wonderful people who are enrolled in this online class, thank you again, for these are wonderful and short, yet somewhat confusing examples. Hopefully for the future videos, this will be a little bit more simpler. But I appreciate you, and thank you. Till next time.